Okay, so in this video, we are going to solve this particular problem on GFG. The name of the problem is kth element of two arrays. Let's see what this problem is saying. We are given two sorted arrays, A and B, and an element k. The task is to find the element that would be at the kth position of the combined sorted arrays. Okay, the final combined sorted array for the example 1 would be 1, 2, 3, 4, 6, 7, 8, 9, 10, and the fifth element would be 6. Yep. Okay, so we need to find the kth element in the sorted array after combining both the arrays. So let's see this with an example. Let's take the first one. Okay, so combining A and B would give us, let's say C is the combined array. So C will look something like this: 2, 3, 6, 7, and 9. These are all the elements that A has, with all the element that B has, followed by 9, 1, 4, 8, and 10. Now the sorted version of C would be 1, 2, 3, 4, 6, 7, 8, 9, and 10. And the fifth element would be 1, 2, 3, 4, fifth. So this will be the fifth element. So since k is 5, so we'll be returning 6 as our answer. So this is the method that they are asking us to follow. But how we are going to solve this problem? Basically, we need to merge these two sorted arrays. So A and B will be sorted at the very beginning. Yeah, given two sorted arrays. And if we try to merge them, then what is going to be the time complexity? Let's see. So both of them can be up to 10 to the 6. So if we try to merge them, so it will be 10 to the 6 plus 10 to the 6 log 10 to the 6 plus 10 to the 6. So this is going to be the time complexity that it will require to sort this array from this one to this one. This is the time complexity that is going to be required, but since this one is greater than 10 to the 8, so that's why it is going to give us time limit exceed. So what we are going to do, we are going to follow another approach. What we are going to follow, we are going to use two pointers. So what is two pointer? Basically two pointer is the approach where we use two pointer to point to two element, in this case for two different arrays. Let's see how this will work. So A will be 2, 3, 6, 7, 9. So in total there are 5 elements in the array A. Similarly in array B we have 5 elements. No, we have 4 elements. These are 1, 4, 8, and 10. So what we can do, we can basically create another array by using two pointer, or we can simply find the kth largest element by moving these pointers whenever we find whichever is the smaller one. For example, if we try to sort this without using the inbuilt sorting method or without using any sorting algorithm, then how we are going to sort this using this two pointer method. So basically, let's say this will point, like P will point to the first element of the array A and Q will be pointing to the first element of array B. So initially the value of P would be 0 and Q will be 0 because both of them are pointing to the 0th element. So what we'll do, we will check which one of these two is the smaller one. So basically P is pointing to a element that is that is pointing to a value which is 2, and Q is pointing to a value which is 1. So since 1 is smaller than 2, so we'll take the one that is pointed by Q and we'll add that to our array. So this array will Q will point to the element 4 which is at index 1. So after that, what we are going to do now, basically we are going to see that which one out of these two is smaller. So since 2 is smaller, so we are going to update the value of P by 1. So now we'll take 2 from here and we'll append 2 to here. Now we'll again check which one out of these two is smaller. Since 3 is smaller, so the value of P is going to get incremented by 1. Now value of P will be 2. So P will be pointing to this element and this value will be added here. Similarly, we are going to do this for the rest of the array. Now 4 will come here and this way. Like value of Q is going to change by 2. So Q will be pointing to 8. Now out of 6 and 8, what is the smaller value? 6 is the smallest, so we are going to increment P by 1. Now P is going to point to the third index, that is 7. We are going to take 6 here. Now out of these two, 7 is the smaller one, so we are going to take 7. We are going to update P by 1. Out of these two, 8 is smaller, so we are going to take 8 over here. We are going to update our Q. Now Q is pointing to 10 and P is pointing to 9. So since 9 is smaller, then we are going to take 9 over here. Okay, this should be 4. 10 here. So 10 will come over here. That's how we'll get our sorted array without using any sorting algorithm. And this whole approach will take big O of n plus m, where n is the size of the array A and m is the size of the array B. Now since both of them can be as big as 10 to the 6, so this algorithm will take 10 to the 6, big of 10 to the 6 time complexity at max, which is not greater than, which is less than 10 to the 8, so it will pass. So let's implement this in our code. So to implement this, we are going to create another array C, and we are going to keep track of 2 pointer. So let's say that 2 pointer of P and Q, which are initially given a value that is 0. We're going to create an array which initially will be empty. Let's call this C. Now this process will continue till there is any element left with in either A or either B. So while P is less than A dot size or Q is less than A dot size. So first thing we need to check that if both the variable are less than the size of the array, so both of them are pointing to a valid index, not the end of the array, that we need to check at the very beginning. So if P is less than, so instead of using A dot size every time, we can store them in a variable. Let's say NA is the size of the A array and NB is the size of the B array. So we are going to check if both of them are pointing to a valid index. Then what we are going to do, we are going to compare which one of them is smaller one. So suppose P is pointing to a element that is smaller than the element pointed by Q, then we are going to update P and we are going to append this element at the C array. Okay, we need to first keep the condition over here. If the element that is pointed by P is smaller than the element pointed by Q, then only we are going to do this. Otherwise we are going to do the complete opposite with the array B. So Q is pointing to the element at array B, so we are going to push that element. Now if any of the array any of the pointer come to index that is not valid, then we are going to do this for the other. We can modify this code. We can modify it to be iterate only when both of them are valid. So instead of giving this if condition here, we are going to continue doing this until this thing is true. That way the code will look a bit cleaner, I believe. Yeah. Now we're going to check if there is any element left in any of the array. So while p is less than na, we are going to append all the elements that are remaining in the array A. And we are going to increment the value of P. Same we are going to do for the array B as well. Since there are any element remaining in array B, we are going to append all those elements in the array C. Now we are going to return the kth element in the array C. Since this is a zero based indexing, we need to return k minus 1th element to get the kth element. Let's see if the code is passing the example test case. Yes, it is passing the example test cases. So we are going to submit this code. Okay, there is some issue. It is giving segmentation fault. Generally, segmentation fault occur when we try to access a memory that doesn't belong to us. So we are doing comparison in with P here. We should be ideally doing it with Q. Now let's again check this with the example test case and try to submit. Yeah. So it is passing all the test cases. Thank you for watching. See you in the next one.